All right, welcome to 9.2, and this is the first one. We're not doing 9.1 or we come back. I told you we do these things out of order. And this is series, partial sums, convergence, and sum of infinite geometric series. Sum of infinite geometric series. That's what SOIGS is, okay? All right, so let's talk. What the heck is a series? A series looks like this. N goes to 1, there's a sigma, and it goes to infinity. And it adds all these numbers up. This is an infinite series. All right? The sequence of partial sums are, the first sum would be this one, the first element. The second sum would be the first two elements added together. The third sum would be the first three elements added together. And the nth sum would be all of them added together. All right? By the way, if you want to show in between, if you want to show foreverness, it's 3 dots. It has to come after the operation. There actually should be a plus here. If you show in between, you should show an operation, 3 dots, a plus, just some notational stuff. All right? So, if the series converges to some sum, or S, that is the sum of the series. If the series diverges, then the series diverges. So, let me show you how to do this. It's very simple. What we're going to do is we're going to plug in 1. So we're going to say something like this. We're going to say, okay, S of 1, the first sum, partial sum, is when n is 1. When n is 1, I get a half. We're doing series. Yes, yes. Sum of 2 is going to be 1/2 plus, when it's 2, it's 1/4. We're cooking with oil now. Now we have the third sum. Okay, what's the first 4 terms of the partial sums? So now I'm going to go to 4. So this is going to be 1/2 plus 1/4 plus 1/8. And then the last one, S of 4, let me back it up, give you some room. It's going to be 1/2, 1/4, 1/8, and then like 1/16 as an answer. Whoa, there it is. Now, if, and there's a big if it was n equals 0, then the first 4 sums would look like this. S of 1 would be, or S of 0 would then be 1. Okay? And that's the first term. So you got to be careful what they ask for. They ask for 4 terms, then I'm only going this far. If n was 0. If it asks for n equals 4, then we go to n equals 4. So just be careful what they ask, okay? And that's a little semantical, but that's what happens. Over here, convergence versus divergence. A geometric series looks like this, all right? A times some r, where r is the common ratio, raised to the nth power. And we show the series that looks like this. A geometric series with ratio r diverges if the absolute value of r is greater than or equal to 1. It converges if the absolute value of r is less than 1. Perfect. So this tells you when it diverges, this tells you when it converges. And guess what? When it converges, we have ourselves a formula. A over 1 minus r will be the sum. So in that one I showed you before, okay, in that one example I showed you before in that other page, okay, look at this. It's 1 over 2 to the n. That can also be written as, you ready? I'm going to do it in red right down here. The sum of 1/2 to the n power. Okay? 1/2 to the n power. So my r is 1/2, the absolute value of 1/2 is less than 1. Voila! This guy converges. And it converges to some sum. There it is, converges to some sum. It converges to, well, what's the A? If you don't see the A, it's 1 over 1 minus 1/2, which turns out to be 1 over 1/2, or 2. Hope I did that right. I'm pretty sure I did. Okay? And that's what we're going to be doing for all these. So let's take a look. Converge, diverge, y. So this turns out to be 3, and sometimes you got to rewrite it a little bit. 3 times 1/2 to the n power. Well, this one converges. Converges because 1/2, the absolute value of 1/2 is less than 1. Okay, what's the sum? It's going to be a over 1 minus r. 3 over 1/2 is 6. So it converges to 6. So far you're liking series, I hope. Not so bad. I told you I'd ease you into it. Next problem. This one. Ooh, diverges. Because why? Diverges, I guess that's spelled right. Because 3/2, the absolute value of 3/2 is greater than 1. Look at the next one. Sometimes they don't give you the sigma notation. They'll give you some of the terms of the series or elements of the series. So I recognize this to be the first one, second one, third one. I also recognize this to be this. 1/10 and 1/10 to the nth. This converges. It converges because, once again, because 1 over 10 is less than 1. And it converges to 1 over 1 minus 1/10. So that's going to be 1 over 1, I don't know, 1 over 9/10 or 10/9. That'll be 10/9. Okay? Any questions? It's pretty good so far. Let's do the sum of the series. Find the sum of the series. And I kind of got the out of there. Let's make it nice. All right. So now we're given something that looks like this. And I can't use that a over 1 minus r because it's a little different. So what I'm going to have to do is I'm going to use something called partial fractions. You remember how to do this? All right. I'm going to make this be the same as a over 2n, the difference of two squares, 2n plus 1, b over 2n minus 1, and when I add them up, I get something equal to 2. So I'm going to get a times 2n minus 1 plus b times 2n plus 1, and this equals 2. So now if I set n equal to 1/2, if n equals 1/2, this guy goes away, and I get 3/2 equals 2. Is that right? No, I get b to be 1, because I get 1/2 of 2 is 1, 1 plus 1 is 2, 2b equals 2, so it's 1. You've done this before with integrals. Now if I set it n equal to negative 1/2, then this will become a equals negative 1. And you may remember that there'll be opposites if this is just a number. So this whole thing turns into infinity up top, n equals 1, and let's watch the fraction. This is going to be 1 over 2n minus 1, and this is where actually your number skills are going to come in. Okay, so I have just changed that to that fraction. Let's plug in some numbers and see if we see anything. Okay, now I'm going to plug in some numbers. Plug in. So I'm going to plug in 1, and I'm going to get 1 over 1 minus 1/3. And I plug in 1. Plus, I'm going to plug in 2, and I'm going to get 1/3 minus 1/5. And then I'm going to plug in 3, and I'm going to get 1/5 minus 1/7. Now wait a minute. Can you see this pattern? This and this, because we're adding them, will go out. This and this will go out. So my last one is going to be 1 minus 1 over 2n plus 1. That's going to be the last one. That's going to be what's left. This 1 is left, and this guy's left. Okay? So now I'm just going to take the limit as n goes to infinity. So basically, I broke this down to this, then I broke this down to this, and now as n goes to infinity, this guy goes to 0, and this guy converges to 1. Okay, and it does converge. So far, we're good. Let's do another one. Here's an example here. Okay, 3 minus 1 plus 1/3 minus 1/9. Well, let's think about this. A is the initial amount. It looks to be going up by negative 1/3 each time, or multiplied by negative 1/3. So I think R is going to be negative 1/3, so therefore this thing is going to converge. This has to converge if negative 1/3 is less than 1. Absolute value, of course. So now they say if the sum is equal to, from the last slide, A over 1 minus R. It's plus 1/3 because it was minus and negative 1/3. This guy turns out to be, I believe, I don't know the answer. I think it's going to be, this becomes 3 over 4 over 3, 9/4. So different things to look for. You look for to see if it's geometric. You try to do this if it's a partial fraction, and those are the type of problems you'll see. Let's talk about homework. I would like you to do, forget about 27 and 28. Look at me just taking homework away. How great am I? Right now, I hope you're not like Miss Carrie cursing me out or something. All right? We're going 6-14, 1 to 5 odd, 9 to 12. And then we'll do some in class. And just the big gist of this, there's two things here. One was the partial sums, okay? The second one is this formula with the geometric series. Have fun, good luck. Here's some answers for you. So if you want to pause them, no, that's not them, I'm sorry. My bad. Okay, that's something else. Here's the homework again. Take care, enjoy.